Previously, you've seen me use a board that looks like this, just a power distribution board. I have a few different flavors of this as far as how I populated them, but this is an example of a board that basically allows me to take in power. Usually I come in with a DC barrel connector from my power supply, and then I can distribute it through a variety of different types of connectors. This being one style of connector that I found very handy that I can just quickly plug in and then plug this into another card or board, whatever it might be. Here's another example where I plug into a breadboard, so I can go like this and plug this into a breadboard and get power that way. So this card has been great, and it's not anything fancy, but it really is just giving me some quick physical distribution of power. Another card, though, that I have used is this clock reset card, and a pretty basic card again. Basically sends out a clock, an inverted clock. I can go off of a slower 555 based clock. I can manually pulse it. I can also run an oscillator, and the output is run out through a 7474, and that is a flip-flop, so that I get a nice clean inverted clock along with my main clock. I can also do a delayed reset with this. That reset duration is adjustable, so when it first powers on, it keeps my processor or whatever board I'm working on that reset low for an amount of time. Or if I press the reset button, of course, it also resets that way. These have been handy, and more recently on my 286 build, I just put in a footprint just to remind me of the space it's going to take, which would be this card here. Well, I actually have that card in now, that PCB, and what I'm going to do in this video is go through the build out of that. I think I'm going to start with just simply loading up the power circuitry here. Basically, I can now take in power from banana plugs, which will be great. I should see that I've got power with an indicator. And then the rest of the board is not powered. It's not going to give any output power unless this relay is turned on with a switch. So I've got an on-off switch for power for the rest of my system. And with that, I also have an indicator, LED indicator. So I want to test that first, make sure that that part of it is working, because that's brand new, I guess, as far as my build is concerned. And I've changed a few other little things around, maybe changed from clock source being a jumper to a switch. I found I was constantly jumping back and forth, so a switch will be more handy. And I added a 74269 counter out here that is basically an 8-stage counter, so that I can take the clock that's coming out and have it quarter at 8th it all the way down to 1/256th, so 256th of my oscillator. And actually it's going to be 5/12 of the oscillator. So the reason I say that is the oscillator is going to go through the flip-flop, which cuts its speed in half, and then this is going to further cut it in half again, or a quarter, 8th, 16th, etc. So at this point, I'm just going to go into recording, and I'll do a fast forward playback, and I can comment on any issues or concerns as I go. the assembly is complete, and this is what the card looks like. And so I'll give you a quick picture of the back of that there. I'm not sure how well that'll come through in the video, but this is what it's looking like, and everything appears to be functional without any modifications, which is surprising, but I'll take it. So let me just walk through what I have here. First of all, I can bring in power anywhere in this upper left box. This is input power. And so in this case, I can either go barrel connectors, a DC cable, which typically, if I look at my power supply over here, I would bring in power through this cable. And this is a pretty hefty cable, so it can supply a lot of power. And I can just plug that in right here if I'd like and source power that way. I find that even easier than that is for me just to go with banana plugs straight from my benchtop power supply, so I can plug those in. I could also supply power with one of these types of connectors, maybe from some other system, as long as I just bring it in, and these are kind of a quick connect, so I could just plug in my power there. Or I could even just bring in power off of this little, into this little pin header, so that's easy. So for now, I'll just use these banana plugs on these power supply cables. And I'm going to go ahead and turn on that power. And at this point, the main circuit stays off. If I measure any of these outputs, there's not going to be any output. It's just power in this upper left at this point. And I've got a switch then that will turn on the relay and supply power to the rest of the system. And out of my power supply, I'm providing 5.10 volts right now. And so by the time it gets all the way into the system, it looks like I'm losing a 0.03 volt from what at least my power supply says. So I'm fine with that. I, of course, can pull that down closer to 5 if I want. I usually run just a little bit over. And so at this point, what do I have on here? So I've got an indicator showing that I've got my VCC, and that's the VCC to the circuit and anything it's supplying. This is VCC in, so I'm saying I've got an active feed of power coming in. I have then turned it on for the circuit. My reset is high, and I've got this set up as an active low reset. So if I press the reset button, you can see it holds the reset and then brings it back up. If I turn off the circuit, you'll see that when I turn the circuit on, it also holds that reset down for a period. Or if I just turn off my power supply, again, it holds down that reset circuit. So that's great. You probably cannot hear this on my headset here, but as I turn this on, the relay is clicking. Actually, yeah, it's hard to hear it over the switch. You kind of hear both at the same time, but when I click it off, I definitely hear that relay clicking. So that's great. On the back of this, I've got some pretty beefy traces for the power, so I'm not too concerned about this supplying power. And I can really supply then out of any of these other connectors that you see. So I've got some barrel connectors spread out. I have some blade connectors, or like a screw terminal type connector, 3 of those. And then I've got 1, 2, 3, 4, 5 more of these. So I could go to one of these to a breadboard. I might jumper this to another one of my PCBs somewhere in one of my systems, and I can make those any length I want. So that's pretty handy. I can come over here and just plug in my power and then connect to whatever card where I want to, whatever it is I'm trying to power. So that works great. Right now I've got it set to clock type of auto, and clock source is 555. If I want, I can go to a manual clock, and then I can manually just pulse through. And this is showing me my clock. This is showing me my inverted clock. So when this is on, obviously having both LEDs is kind of pointless, but it's there. And if I do get sick of, I don't want to see those LEDs if they just get annoying after some point. For example, if I'm going off of the oscillator, they're just going to sit like that and look pretty pointless. I have a jumper I can just pull off and disable those LEDs. But for now, I will leave those on. So clock source, auto, manual, 555, oscillator. So those are my choices to work with there. So again, I can go back to my 555, maybe I go to manual, and now I can single step as I'm trying to debug, let's say my 286 system that I'm currently working on. And then if I want to work with the 555, kind of a little bit faster timer than manual pulsing, but not as fast as an oscillator, I can just set that to 555 and go to auto. And then I have a potentiometer I can adjust right here for clock speed. And so I can turn that down, and let's see, the slowest I can go is right there. So that's pretty slow. And then I can slowly turn this up. And it's pretty fine between those speeds to where all of a sudden it gets fast enough that it just looks like you got dim LEDs. But that's as fast as I can go at that point. And if I want, I do have, let's just hook up a scope here quick. Handy thing about these little power pin headers is now I can just take my scope and plug it in to one of those for the ground. And let me get this on there. Okay, so I've got that, and I'm just going to connect up to my clock signal. And then on the screen here, I'm just going to capture what's on the oscilloscope so that you can see it. And so it looks like the fastest I can go with the 555. The way it sits is about 250 hertz. And that's honestly pretty fast for a lot of the initial debugging that I'll do on a system. But if I want to go faster than that, but not all the way up to an oscillator, I'll show you some options I have for that. If I go to the source of oscillator, and I maybe do another capture, you can see right now I've got an 8 megahertz, and I can spread this wave out if we want to see it. And I'll just do a single. So then I've got a clock signal that looks like this. So I got a 5-volt peak to peak, 8 megahertz roughly, or 7.988 is what I'm seeing there. And that's 16 coming in, going through a flip-flop, hence why I'm getting the 8. Now the nice thing is I can then come down here, and because I put this counter in, I can just connect to any of its basically stages of its count. And let me go back to auto and show that real quick. And so now if I grab a screen capture of the oscilloscope again, you can see I'm now at 4 megahertz. And so I could go all the way down here, and the very last pin coming out of this at this point is all the way down to this 31.25 kilohertz. So there you can see what that looks like. And so if I wanted to go somewhere in between 35 kilohertz and the whatever, the couple hundred hertz that I was getting on the 555, I can just turn this off and put in, let me just grab my smallest, well, let's see what I've got for oscillators here. I think I have maybe a 1 megahertz in here somewhere. Let's see if I have one handy or not. That's a 60. And let's test that one here in a second and see if this card gets upset with a 60. Okay, so this is a 1. So 1 megahertz can, and I'll go ahead and turn that on. And that now means that I am getting down to 2 kilohertz. So I'm at 2000 hertz. So I've got to jump between, on the case of the 555 at the fastest, would be up here. And so I'm jumping from a 250 to a 2000. Being that I can get this so slow now, so if I'm on my 555 and I turn that all the way down, it is so slow. And then by the time I take this and divide it by 256 down here, actually, divide it by 256, that's a really, that's too slow. So that means what I could do is I could update my 555 circuit by just changing the capacitor or resistor, speed that up a bunch, and maybe close that gap between the 250 and the 2000. Honestly, it doesn't matter for me. 200 hertz is plenty fine for when I'm doing my initial debugging. And then if I can run off of a can all the way down to a couple thousand, that's plenty slow. and then of course I can step that all the way up. So that is a nice way for me now with a 52 or with a 555 setup and a single oscillator to get some pretty good options out of this. If you have any questions or feedback, suggestions on how to make this better in future revisions, I did have one suggestion to maybe add an additional power in type, which might be like an ATX power supply, and that would be easy to do. So I could take in at least the 5-volt line off of that. I wouldn't do anything with the 12-volt or any of the negatives, -5, -12, or anything like that, but at least not in the way I currently use this type of a board. I'm doing only positive 5-volt. Thanks for following along on this. The next thing I'm going to do is now get this tied in to my 286 setup, and I'll go ahead and get moving on that here in the coming week. And then at that point, I should be able to see if I've got some signs of life in that new build number 2 that I've been working on for my 286.